I'm Lakshmi. I've got 20 plus years of industry experience, and of which more than a decade has been in the space of AI and ML. So I've kind of seen this space evolve. And more recently, I'm working in generative AI and experimenting with the various LLMs. So today's topic, right? Extracting structured data from text. So why is this topic even important? Some of us might have worked with unstructured data, would have extracted data from these texts. But in the interest of those folks who are just getting into AI, let me give a brief background. So unstructured data is anything which doesn't have a predefined structure. So this could be your documents, your emails, social media posts, anything of that sort, right? And then let's take the example of a document, right? Say the annual report of a company. So the good thing about it is it has a whole lot of information. So you will have the cash flow documents, the revenue, the corporate governance structure, everything is inside that. But the not so good thing about it is that the data is kind of all over the place, right? So it could be a 50-page document, a 100-page document, and the data could be in different paragraphs, different pages, different sections, kind of everywhere. So one of the crudest way in which we can kind of extract this data is literally read through this document, and whenever you find something interesting or something that is of value to you, put it onto a web form, right? And early days, another way of doing it was using regular expressions. Technology evolved. Then we had named entity recognition techniques, which could kind of pull out data like, name of the people, name of the organization, places, dates, and so on and so forth. So what is happening over here is this unstructured data is being converted into a structured data, which means that it is having a predefined form, right? So this could either be your database tables, it could be your Excel files, it could be something like a XML file, or it could be a JSON. So all of this is what I would call the structured format. And then once you have the data in the structured format, you could do analysis on them. And by analysis, I mean, you could look for trends in these data, right? Or you could kind of say it's a set of customer reviews. And then you can see what is it that the people are talking about. So maybe they're not happy with a specific feature of your product, right? So you can identify all of this by analyzing this data. And then once you have this insights, you can kind of translate that into action, which could be, in the example that I took, go back to the drawing board, do something about that specific feature. So let me get into a more specific example, right? So this is a text from the Yahoo website, which basically talks about the US Open 2023, where Coco Gauff won the tournament. And then, you're given the task of extracting some attributes such as name, birthday, profession, and home country of the individuals mentioned in the text. So the problem here is that for one specific text, the data is in a specific format, right? And then as a human, how would you go about doing that? So basically, you would kind of read through this document, highlighting the data points which are available. And at the same time, the ask here is to look for the birthday and home country of all the individuals. But you see that data is not readily available. As for Coco Gauff, her age is mentioned, but the birthday is not mentioned, right? So there's a partial information there as well. So what would you do? So you would either look up some other documents, or you would kind of Google that and then get the relevant information, right? So now we are in the world of generative AI, and we don't really have to kind of read through these documents. So what do we have to do? Right? So I guess most of you would be familiar with prompt, but to put it in simple terms, prompt is nothing but a way to communicate with the large language models. And I have given a notebook in the GitHub, which has the whole flow, but I wouldn't be going through that notebook here in the interest of time. I've just put a screenshot of the prompt here. So in the prompt, basically, you specify the instruction is to extract data from the text. Text is what I showed you in the last slide. And along with that, you will have to give a set of instructions to the LLMs. So you'll have to say that, you extract whatever the attributes you are interested in. And you also will have to give specific examples. Because suppose you don't give these two examples, it would still extract the required data points, but the JSON would not be formatted this way. It could be, for example, return birthday in one case, it could return date of birth in another case, and so on and so forth. And again, we have the problem that not all the data is available in the text, right? So in that case, you give an additional instruction saying that if any details are missing, perform a search to find the required information and fill it into the JSON response. And we also kind of tell the LLM that if you do not have enough information, then notify me. So you have written this prompt, and then you kind of give it to the LLM. And what happens is you get a response. So in the top right corner, again, I've put a screenshot of the data that has been extracted. So just to ensure that it's not hallucinating, I just pulled the information from Wikipedia. So everything is matching. So it's all good. So now that you have the data, then your use case starts, right? So the simplest use case could be, okay, I have this data, I'll just put it onto a database. Or another use case could be that, okay, I have these people, I might just send them to a downstream application. Or you could kind of analyze the data of the different individuals that you have here, and then have, say, maybe arrange them in the increasing order of their age, or put them into different buckets depending on what their profession is, so on and so forth. So the use cases are, or the logic with which you process this data is completely dependent on you. Okay, so you have prompts, which are a way of doing it. And now let's get into function calls. So I talked about the function, which would basically take this extracted data as an input and do the other processing on that. So with function calling, in most simple terms, what's happening is you just have to give that function name and the parameters to the function as to the LLM, and it would extract that. So you wouldn't have to write as detailed a prompt that you did in the previous case, right? And you don't have to give any examples. So how is this made possible? OpenAI released two models in mid of June, which is the 0613 versions of GPT-4 and GPT 3.5 Turbo. And both of these models are fine-tuned in the sense that they can detect when a function has to be called. And also, their response is a JSON object, which basically adheres to the function signature, which is basically the input parameters of the function in simple terms. And this whole function calling takes place in 3 different steps. So I'll get into it as we work through an example. And OpenAI has listed the various use cases. There are multiple other areas also where you can use function calls. But today, I'll be taking you through the use case extract structured data from text. So let me just switch over to the notebook. So what I have done is, in the interest of time, I have pre-run this notebook. And I'll just be taking you through the inputs. So to run this notebook, you'll need a OpenAI API key, which you can get it from platform.openai.com. And in this notebook, I've kind of provided two examples, but I'll be taking you through the one which we talked about. Right? So the first step, as always, is to install all the required packages. Post that, we import them. And next step is to load the API key. So it's always a good practice to put the API key in the environment file and use it from there. And then comes the function. So here I have defined a function called format.json, which takes one parameter, which is a list. So for the demo, what I've done is I've kept it very simple. So this function would take a list and output a JSON formatted string there. But this is the function where your actual business logic would come in. I've also given a very small example of how this function can be called and what output it gives, right? And then we start with the text. Again, we are using the same text that I showed you there. Then we start with the first step of OpenAI function calling, which is to call the model with the functions and the user's input. The first step here is to define the function. So all the functions that you can define multiple functions, and all the functions you kind of put it into an array called functions. So, and for each of the functions, you give a name, a description of what it is supposed to do, and followed by the JSON schema of the parameters. So I'll just, can be a bit confusing, especially if it has got multiple, nested objects. So here we say that the input is an object, and which is basically of type array, and we name it people. And inside the people array, we have an items object. The items object in turn contains a name, birthday, profession, and home country. You have to define the type of all of them, which is string here. And you also need to give a description of these elements. So once that is done, you could always specify what are the required parameters and what are the optional ones. So here there's only one function parameter, and I've put it as required. And then, we need a mapping between the name which is mentioned here in the function as well as the actual function name. You would also have specify the messages. Suppose that you call the chat completion API. Once you call it, this is the response that you would get back. So it would say that, the response is like the role is assistant. It's coming from the LLM. And along with that, there is a property called function call, which has a name and the arguments. So in the arguments part, all the entities that you wanted to be extracted are returned by the LLM. Just remember, we have not made the function call as yet. We have just called the chat completion API with the list of functions. And once that is done, we basically extract the function name and the arguments from there. And the step 2 is where you call the function. And once that is done, you get the response. So here for me, the response is kind of almost the same as the input, because it's just a JSON formatted string that I'm outputting. And then once that is done, you could send the response back to the model to summarize. To do that, you need to append 2 things to the message. One is the first response that you got from the LLM, which was basically the function call with the name and the arguments. And then you also need to append to it another message with the role as function. The name would be the function name, and the content would be the response from the function, right? So once that is done, you again call the chat completion API. And here what happens is now the ChatGPT is kind of taking all this data and giving you a response which is in a more user-friendly format, right? So it says that Coco Golf born on whatever dates and, gives all the details. So this is how a typical flow would be there. So I've kind of provided another example as well here, but I wouldn't be kind of going through it. And all the examples that I talked about is there in the GitHub. And I've also provided my LinkedIn URL, so feel free to connect with me. And I guess, yeah, that's all I had for today. And any questions are welcome. These days, RAGs, vector databases, they're kind of everywhere. So for me, how I see it as, this problem has existed for years, where you have to kind of get the most recent and relevant data. And the volume of data is just increasing, right? It's like explosion of data. So once you have, techniques like embedding, and then you have, say, to take an example of, say, Pinecone or other vector databases, the whole effort is kind of reducing, right? So that's how I see it. Once you have all of these implementation, the kind of effort and time that you need to implement a solution, either at the enterprise level or at the startup level. So the effort and time are reducing. But again, at the same time, you have to be very careful about the data privacy and the security, right? So I guess it's going to be a very delicate balance. Things are evolving. Are we there yet? I would say no, but we are constantly evolving, and I'm hoping that, one day we are going to be there. So that's my take on it. Yes, some of the models are coming up with something similar in that, which you can use it. So it may not be, a direct function call as in OpenAI, but you could kind of use something like a LangChain to implement the equivalent of a function call. Yeah, but there may not be an exact one-to-one mapping out there. What I have seen as, the world without the function calls, the hallucination or the getting a different format was quite higher. With function calls, it has reduced, but I wouldn't say it's perfect, right? There are still situations where we would kind of see either if I kind of call them as key value pairs, your key is different, right? To take an example, birthday and a date of birth. And what would happen here is your downstream application would break. So again, with function calling, I would say is like after that, put in a check, especially for the data types as well as the keys. So that would kind of help control it to an extent, right? So once that happens, you're doing a check there, and you can kind of, I would say, manually or say programmatically correct it before you move on to the next module. So I would say, build what I would call a set of error checking functions. So this would be one format, could be one. And the other one would be, again, the kind of APIs that you're using, right? The kind of, especially if you're trying to do a text to SQL, the kind of queries that are being generated. It's kind of best practice to put in some conditions to check the kind of queries, the kind of output data from there which is coming in, the data types and everything, because if one day we kind of are able to get rid of the hallucination problem, then we could kind of remove all of those. But until then, I feel we need all of those functions. Yes, this can be scaled. But again, as I said, you will have to kind of put in all the other, this is just a part of it, right? But around this, you will have to have a support structure of all the kind of data validation and everything before you kind of put it onto production, right? So it is scalable. You just need to kind of plan for it, provide maybe, a backup call, because it can happen that your LLM calls might fail as well. But once you kind of build the whole support structure, yes, it can get into production. I'm not aware of the specifics of Tiger Graph, but yes, knowledge graphs and LLMs together would be a very powerful tool, especially for extracting data from these documents or making relevant connections, or say question answering based on or retrieving similar documents. So all of those use cases, I see a combination of this going along.